Well, first of all, my name is Artem, and we're going to talk about full stack testing of web applications written in JavaScript tonight. A bit about myself. I've been a web developer for 12, 13 years, starting from Perl, then moving on to Ruby on Rails, and then Node and JavaScript. Now I'm actually back on Rails. I don't plan to go back to Perl. I work for a UK-based consultancy called Featurist, and myself and my colleague, we represent what we call the continental arm of the company. We live in Thonon-les-Bains, which is, as you know, right across the lake. In Featurist, we do obviously web, we do mobile, we do machine learning, DevOps, all that exciting stuff. So if you need any of that, come speak to me after the talk. And we're also pretty serious about testing, automated testing, and which is why I'm here sharing some of our experience tonight. So let's start with going over types of tests we normally find in the project, just so we're all on the same page. So roughly speaking, broadly speaking, we've got two types of tests. Unit tests, a tests that take a small unit of code, such as a class or a module, or a function. And we've got integration tests. So those tests make sure that when those units are put together, everything still works. Now all those tests have their own pros and cons. Let's quickly go over these. The good things about unit tests is that they're easy to write. They're easy to write because all we need to do to exercise the behavior of a class is just to call a constructor on it and a couple of methods, pass some parameters. It's all easy stuff. They are really fast, obviously, because the whole test runs in the memory. It's just objects and it's instantaneous. And they have good feedback, by which I mean when something goes wrong and the test fails, we normally present it with a stack trace that points right at the heart of the problem. The not so good parts of unit tests are that they have small coverage. Obviously, they only cover a tiny piece of a functionality of the whole system. And to have some reasonable confidence overall, we've got to have quite a few of those. They do not cover glue code. By glue code, I mean the code that is there to, put the units together. And in large systems, as we know, there's plenty of that code, and often even, more often than not, the logic creeps into that code as well. So unit tests, by definition, can't cover that. And finally, lots of unit tests make refactoring hard. Well, unit tests, by its nature, they tie to the implementation details, to particular classes, particular modules, particular internal interfaces. And of course, when we want to change that stuff without changing the behavior of the whole system, we're facing with the prospect of also changing a mountain of unit tests, which is a discouraging factor of it. On to the integration tests. The good thing about integration tests is that one single test can cover a lot of your code. All the layers, UI, database, and how the data flows through. So that's really good. That's very valuable. We get a lot of value out of just one single test. Obviously, it covers glue code because it doesn't have any even knowledge of what's inside. It just exercises your system as a black box. And importantly, those tests are a good choice to cover the user interface, which unit tests aren't really good at. On the downside, we have a complex setup. compared to just instantiating an object, we often have to prepare data in a particular shape, stage, all manner of subsystems to be in a particular state, and then we run our test. So more often than not, and most of the time of writing such tests actually goes into the setup, and then into understanding what kind of setup, what's going on there when something goes wrong. So the complex setup is definitely a downside. They are also slow. Often we need to start servers, we need to bundle JavaScript, we need to do all sorts of things, and then of course all those things run in separate processes, which doesn't speed things up as well. And they're hard to debug, again for the same reason, because there's so many moving parts, and often what you see when the test fails is just something in the interface is missing, or maybe there's an error message. And now you have to go through the whole stack and figure out where exactly the actual problem is. So it's, compared to the stack trace, it's a lot more work. So in a nutshell, we have unit tests that are easy but of limited value, and we have integration tests that are painful but of basically ultimate value. But of course, the value factor only becomes clear later on in the project. So often when we start, this doesn't really matter all that much. So it all comes down to just these two things, easy or painful. And obviously nobody wants to do painful. So, we just do that. And that happens quite often. But of course, it's only a matter of time till something like this happens. As we can see, all the units are working pretty good, but when you put them together, it's not quite the behavior we expected, right? Or maybe this is even better one. Yeah, that's what it means. No integration tests. So people who understand that, who've been there, who've built those things before, they know that they just can't get away without no integration tests. So a typical project, typical healthy project, would consist of few integration tests, lots of unit tests, and some kind of a mixture of the two in between. Somebody called them functional tests, and so on. And this kind of pattern have been put into a healthy visual metaphor, which is called test pyramid. As we can see, there's a small top of the pyramid of the slow and expensive tests, and large base of the pyramid, which is fast and cheap. But of course, if, for example, if in theory we could make those tests faster, then, since time is money, we could make them cheaper and maybe even turn the pyramid into an ice cream cone or something. So let's have a look once again at what is actually so painful about integration tests. The complex setup is a complex problem, and it's very particular on a particular project, so we're not going to talk about that now. But the other two are, in part at least, are imposed by the tools we're using to write and run those tests. And the mainstream tool people use for such tests is called Selenium WebDriver, which is a browser automation library. It works, roughly speaking, it works by running your test code and your server side in the test process, and then starting a browser separately with your that runs the browser side of your application. And that separation of of tests being broken into multiple processes. This is, in fact, a source of a painful debugging experience, because if you want to pause your system in a particular way, in a particular place, you suddenly have to synchronize, two sets of breakpoints. It's just not a very pleasant experience. It also makes it slower. Not only those two processes have to communicate between each other, but also when the client-side code has to be bundled before, which takes time. So if you're working on a particular test and trying to get it fixed, rerunning that test is not fast. And of course, I wouldn't be saying any of that stuff if I didn't have some kind of a magic solution here, which I do. And it's called Electron. How many of you have heard of Electron? Probably everyone, yeah? But people know Electron as a platform for building desktop applications for using web technologies. What is less known fact about Electron is that how it achieves that is that it allows us to run, it allows access to both DOM API and Node API in the same process, which means that in the same script on 2 lines you can have document query selector all and some file manipulations, which is, if you think about it, pretty a fundamental ability to do. You just wouldn't think that would be ever possible, right? There's a browser code and then the server code. But in Electron, you can have both of those things together. What that means in terms of testing, well, first of all, we can start a test where both sides of our application, server and client, run in the same process, and the test as well. And it also means, since it's a Node API, so all your imports and requires, everything works. You don't need to bundle anything, which makes things faster. So now I'd like to demonstrate you the real application. Well, it's a demo application where I run a couple of tests, full stack tests with the browser side, with the server side, and with the database, using Electron. Okay, so I need to switch a couple of screens here. Bear with me. So let's see. What do I do this? No, that didn't work. Oops. Oh, there you go. Okay, right. This is the application we've got here. It's very simple. It's a form that's showing users to do. The interface is the React application. The server side is the Express, and there's SQLite database. So it's pretty simple. If we search for user that exists in the database, we got their to-dos. Otherwise, we've got a friendly 404 message. Okay, as we can see, well, I can't really see it, but we have, what's this? Oh, there you go, Bob. Bob could, so, but what about Alice? Alice was just there. Let's start this. Hello, Alice, come on. Okay, this is the Alice, right? So we can see the data comes from the server. It's so cool. Now I need to bring another window there. It's going to be that one. Right. Oops. Oh yeah, running tests. Running tests is going to be like this. Yarn test. And those tests we're pretty fast, right? 100, well, I mean, it's pretty fast test, but bear in mind that those are two full stack tests, right? So the browser, with the server, and with the database seeding. So, which in terms of speed, I think is pretty amazing. Let's look at the test itself. And what's the test doing? So these are two tests. They're using a library called BrowserMonkey, which is, by the way, written by Featurist, and it's pretty self-explanatory what's going on there. It's operating in terms of DOM, so it's finding something, some input on the page. It's typing stuff in there. It's clicking on the button, and then it's asserting that certain things are on the page. Similarly, on the second test, we're typing a name of a non-existent user, and we assert that that there's a not found message. So this is probably roughly familiar with normal UI tests. What is special about this test is you can see further up here, before each test, we do this thing called seeddb, and that thing does no less than just, creates the files, or actually just removes the file from the file system, seeds the database, and then it starts the Express server, listening on the port 6365. So all that happens inside the Electron browser. So stuff that would normally go in a separate process all happens in there. So I know you probably don't really trust me just based on that. So let's actually see that in action. Oops, if I could type interactive, there you go. Right, so this is the same test. You can see the same tests are put here in the Electron browser, and running again pretty fast. Now, the most exciting things of all that is when the tests don't really work and we want to start debugging it. What we can do here, we can do typical stuff like, oops, that's the wrong one. This one. So we can see our test, we can put breakpoints. Let's say I'm going to put a breakpoint in here before the request goes to the server. We run the test just simply by reloading the window, and here we are. So that's all fine. It's all pretty familiar.
Your OBS crashed.
My what?
Your OBS just crashed.
Oh, really? Okay, start recording. How's that? Is that better?
Yeah.
Okay. Okay, so speaking of limitations of Electron, probably it's incompatible with OBS, so don't use them together. So let's have a look at the client side code, which is here. Now again, this is probably very familiar because we're running the test, we're running the client-side code. All those breakpoints are fine. So this is the place where we go and make the request. Okay, and we're here. Now watch this. How I will look at what's going on this server, and I can. As you see, I am now in the Express application, and this is the endpoint it's going to be hit, and we can just put a breakpoint there, press the button, and voila! As you can see, the data it's just been queried from the SQL. There's no client-side stuff going on now. This is a hardcore server-side stuff, and we can go back to the client code, and the whole test is waiting. This is all just one flow. There's no distinction between server-side and client-side anymore. This all just works. And here we are, we have a response. For some reason, I think because of JSX it's not highlighted, but it is there. Okay. Well, this was the second test. Okay. And it's important to stress that there's no real magic going on there. There's no hacks. This is a pretty fundamental part of the Electron, which is a established mainstream technology, and for one, we have been using that technique of writing such tests and running them on production on client projects, and it has been serving us really well. So yeah, the tests, a bit of a word on a test stack. We have all this is possible by the following tools: Electron Mocha, which runs Mocha tests, the regular Mocha test inside Electron, and the Browser Monkey, which I have already mentioned, which provides DOM interactions and assertions. And of course, you can use any library or no library for DOM interactions and assertions, because it's just DOM. It's just Browser Monkey is specifically designed to do things like, if you can see all those awaits there, it's designed to work with single page applications, so it implicitly waits for things to appear. So you're not going to get those flaky tests where stuff just isn't there. Yeah. Well, I lost my notes somewhere. Too many windows. Okay, limitations. Right, so Electron has some limitations, although they're not fundamental. First of all, there are no cross-browser tests. Obviously, everything runs in Electron, which is Chromium. So if you need cross-browser tests, you're going to have either a separate suite or maybe use something else at all. Native modules need to recompile. That's another slightly painful bit, although there are tools that solve that. In the show notes, there will be a link to the test project where it shows how it's done. And the Node version is lagging behind. Right now, the latest version Node of is 13 point something or other, and the latest Electron is 12.8. In practice, that doesn't really affect much, but it is something to keep in mind. So none of those limitations are critical, in my opinion, but there are limitations. And well, this is all I've got for you. And if you follow that QR code or the link, if you like typing, you'll get to the GitHub page of the test project where you can play with it and see how it all is done. And thanks for listening.